So what says here? It says a tower truss. This is a tower truss, okay? That's a tower truss. So a tower truss has a weight of 575 pounds and a center of gravity at G. That's the G location is given. You can see the dimensions. The rope system is used to hoist it into the vertical position. So they've used this rope to put it in this present position. Now, if rope CB, where's CB? Rope CB. If rope CB is attached to the top of the shear leg AC, that's the shear leg AC, this one. And a second rope or CD is attached to the truss, that's CD, another rope attached to the truss. Determine the required tension in BC. We need to find the tension in this one. To hold the truss in the position shown. The base of the truss and the shear leg bears against the stack at A, which can be considered as a pin. So it's a pin connection for this truss structure. Also compute the compressive force acting along the shear leg. Okay, so we need to find what it says here. We need to find, in simple words, the tension in this rope and the compression force in there. So two things, this one, BC, and CA. That's what we need to find. So BC is outside the system. So let's draw the free body diagram of the whole structure, this one. Let's draw the free body diagram of this structure. So what we'll have. So it's pin connected here. So you do know if it's pin connected, it can rotate but cannot move in XY. We've got active weight downward. And we've got a pull force here. I have to draw the free body diagram of the whole truss system. This system. So my question is there any other force? Or these are the only forces acting on the truss system?
The cable force is CD.
CD is inside the system. I'm not going inside the system.
Okay.
If I have to draw the free body diagram of the table, that's the table. If I have to draw the free body diagram of the table, the forces are this one and the center of gravity acting. I'm not looking at the weight of this part or the weight of this part or this part. If I have to draw the free body diagram of the system, I don't go inside the system. Is that clear?
Yep.
Okay, sir.
Any other forces there, or these are the only forces?
I think these are the only four.
Okay, A is pin connected. We've got the rope BC connected at point C, and we've got the weight acting down. So let us see if our free body diagram is right. So that's the free body diagram. So we've got things right. We've got the right forces. Now watch. I won't solve it, but look. This is given, which is 575 pounds. And the beauty of taking moment at point A is that this and this doesn't appear in the equation. The only thing appears is this force and a component of this one which acts here. So that's the unknown force, BCX and TBCY. So by taking moment at A, you can easily get your TBC. Am I right?
Yes, sir.
So that's very easy. You can easily get your TBC out easily. Now, what we are after is, so let me show you the solution so that everyone is on board. So taking moment at A, we get our TBC out. No rocket science. Now, going back to this diagram here, I need to find this thing. This is inside the system. So I need to draw the free body diagram of any one point. I can draw the free body diagram of point C. I can draw the free body diagram of point A. I know BC, so the obvious thing is that we should draw the free body diagram of point C. Excuse me. Now remember, assumption is the mother of all disaster. It doesn't say there's a pulley here, so it doesn't mean that the stress here and here is the same. Okay, there's no pulley, so not to assume. So they are separate ropes, CD and BC. So let's draw the free body diagram of point C. So what comes on point C? I will have this pull force, am I right? I will have another pull force here of the rope, and obviously I will have another force here. 3 forces. Will I be able to calculate AC?
If you look at point C, then not, because at only point C you have one known force and 2 unknowns.
So remember, one known, maximum of 2 unknowns. Come on, how many unknowns? You've got 2 unknowns. If you do sum of all the forces along X and Y, you will get 2 equations. Am I right?
Yep,
Yes, sir.
you could solve them simultaneously.
Yes, sir.
So 2 unknowns, 2 equations, you can solve it.
Yes, sir. But we have to have one unknown too, which we have.
You got one known. Look, here we've got, what did I mention? I said you start your analysis inside where in the frame where you got one known and maximum of 2 unknowns. Now here I've got one known, that is BC, and I've got 2 unknowns. 2 unknowns. So if I do sum of all the forces along X, I will have the component of this one, and this one. If I do all the forces along Y, I will have the component of this one, and this one. 2 equations, 2 unknowns, you can solve it. That clear?
Yes.
Yes, sir.
Yes, sir.
Okay. So I have got this one. See here.